All right, hello third grade. We're looking at the first of 4 problems for this week, and I will read the problem aloud to you. I'll highlight the important information, and I will just kind of think through how I would solve this problem if I were in your shoes. So first things first, what's always important is you want to read the problem to make sure you understand everything. And by understand everything, you want to make sure that you understand all of the numbers that are in the problem, all of the units that are in the problem, all of the language that's in the problem before you start moving ahead to try to solve it. This is a good strategy for any problem, whether that's multiple choice or you have to supply the answer, the solutions yourselves. So first things first, let's read it together. Carrie bought 24 erasers from the school store. He grouped the erasers evenly and gave one group to himself and each of his 5 friends. Which equation shows how many erasers are in each group? And below you see we have 4 answer choices. 6 plus E, and I believe the E in this case represents erasers. So 6 plus E equals 24. 5 times E equals 24. 6 times E equals 24. And 24 divided by E equals 5. So that's all the information that we have. I am going to go ahead and highlight, underline, or bold any information that's important to me. So if you're following along and you do not have a highlighter, you can use your pencil to circle or underline the things that I highlight, just to point those things out to yourself. So what is most important to me, or one of the things that's important to me, is this idea that Carrie has 24 erasers total. The fact that he grouped the erasers evenly is important, because I know that whenever I'm talking about even groups of something, most likely the problem is going to involve either multiplication or division, depending on the context. In addition, Carrie gave one group of erasers to himself, but he also gave groups of erasers to each of his 5 friends. One group here and the 5 groups here let me know that Carrie has a total of 6 groups. So now I have all of the information that I need to begin to solve the problem. So let's write down what is important. So there are 6 total groups of erasers. And again, if you're wondering where I got 6 from, because there is no number 6 in the problem, I have one group here and another 5 groups here. Those 2 together give me 6. Okay? Carrie has a total of 24 erasers in all. Okay? And he grouped the erasers evenly. So this again involves either multiplication or division. Now, this is a multiple choice question, so it makes our next steps a little bit simpler than if we had to provide the answer fully for ourselves. We can begin to use the process of elimination to get rid of the obviously wrong answers. So let's start with answer choice A. Answer choice A is 6 plus E equals 24. Now, we know from the information that we've collected that 6 is going to be part of the equation, 24 is going to be part of the equation, and we're either going to see multiplication or division in the equation. Answer choice A has addition in it, so we can get rid of that choice immediately. In addition, we know that we have 6 total groups of erasers. These other 3 answer choices involve both multiplication and division, but 2 of the 3 involve the number 5. And that 5, again, represents Carrie's 5 friends. But when we just have 5 in the equation, we leave out Carrie himself. So we can get rid of these 2 choices here, which leaves us with answer choice C as the correct choice, which is 6 times E equals 24. And if you're wondering what the letter E represents in this particular equation, or actually all of these equations, the letter E most likely stands for erasers, since that's what we're talking about. And for those of you who went ahead and figured out, well, how many erasers were in each group, the answer is definitely 4 erasers in each group, because 6 times 4 equals 24. That was an additional step. Some might think a little bit unnecessary, but I just wanted to make sure that we had a complete and full understanding of the problem. And just to verify, even though it's multiple choice, we can check our work. We can go 6 times E equals 24. We know that E is equal to 4. 6 times 4 equals 24. That is true. So this answer choice checks out, and it makes sense in the context of the entire problem. I hope this walkthrough made sense for you, and I would like for you to use this walkthrough as a guide when you solve the sample problems that are similar to this one in your packet. Thank you. All right, third grade, we are back with the second problem of this week's problem set. This particular problem is free response or open-ended, which means that you have to supply the answer completely on your own. There are no answer choices. And let's just, I just want to point out that this problem also has 3 parts. There's a part A, a part B, and a part C. So again, you're supplying the entire answer choice, and there are 3 parts. So let's go ahead and read the problem. Caroline has 8 boxes with 2 toys in each box. Part A asks, how many groups of toys does Caroline have? Part B asks, what is the equation for the given situation? And part C says, using the commutative property of multiplication, what is a scenario that can be applied to the given situation? Justify your answer. So I'll read each part again, and we'll see, can we make sense of what's on the page? Caroline has 8 boxes with 2 toys in each box. So the fact that she has 8 boxes and there are 2 toys in each box seems important. Part A asks us, how many groups of toys does Caroline have? Groups of, whenever I see the words groups and of next to each other, that suggests, it doesn't always mean that it's true, but it usually suggests that multiplication is involved. Part B, what is the equation for the given situation? So we'll use the information from the scenario itself and from part A to write an equation for the situation. And when we write the equation, we're going to be sure to label all of the numbers in the equation just to make sure that we fully understand what's going on there. And then part C asks us to use the commutative property of multiplication to create a scenario that can be applied to the situation and then to justify our choice. So let's go ahead and start with part A. Part A is actually pretty straightforward and pretty simple because it looks like the premise or the situation itself basically tells us the answer. So it says Caroline has 8 boxes with 2 toys in each box. Boxes, we can substitute the word boxes for the word groups, and then there's our answer. So how many groups of toys does Caroline have? Caroline, and excuse my handwriting, has 8 groups or boxes of toys. Okay, pretty straightforward. But I'm going to go ahead and draw a picture to represent this situation. It may be helpful to us later. So let's just go ahead and draw what that looks like. So that's 1, 2, 3, 4 boxes, 5, 6, 7, 8. See, my boxes got smaller as they went along, but that's okay. The problem also tells us that Caroline has 2 toys in each box. So we'll go ahead and add that. 2, 4, 6, 8, 10, 12, 14, 16. So we can go ahead and scroll down to part B that asks us, what is the equation for the given situation? The equation we can actually pull right from the drawing we just did. So we have 8 boxes with 2 toys in each box. Or we can look at it another way and say we have 8 groups of 2. So we have 8 times 2. And if we do some skip counting, we'll see that we have 2, 4, 6, 8, 10, 12, 14, 16 total toys in all. So let's go ahead and label that and make sure that we are super clear about what every number represents. So the 8 is the boxes or the groups. The 2 represents the toys in each box. And the 16 represents the total number of toys. So I think that is super clear. Okay, now that we finished part B, let's take a look at what's going on in part C. Let me grab my trusty highlighter here. I'll use a different color. Part C says, using the commutative property of multiplication, what is a scenario that can be applied to the given situation? Justify your answer. Before we can even answer that, we need to be very clear on what is meant by the commutative property of multiplication. Now, I like the website Wolfram Alpha to support my learning in mathematics. So that's the website we're going to use to help make this concept clear. So there is a definition for the commutative property of multiplication. And the definition is a pretty simple one. It states that any two numbers can be multiplied in any order and we'll get the exact same answer. So if we scroll up a bit and take a look at the example that's on the page, we can see a visual model of the commutative property in action. So we have this array model, and this particular array has, let's see how many rows. It has 1, 2, 3, 4, 5, 6 rows and 1, 2, 3 columns. So 3 columns times 6 rows gives us 18. But if we turn that array on its side, then we have 6 columns and 3 rows. So in this case, 6 times 3 also gives us 18. And that is something that is actually always true, okay? If you have 2 factors and you're multiplying them, it doesn't matter the order in which we multiply them, we'll always get the same answer. And we can play around with these little sliders up here to show that this is always true. Let's see what's going on with our sliders. Oh, looks like the website crashed a bit. Let's refresh. Okay. So there's a live version of the sliders that shows us that if we reverse the factors, we'll always end up with the same product. So 3 times 4 is 12, 4 times 3 is 12. Okay. 5 times 4 is 20, 4 times 5 is 20. Let's see what happens. 7 times 4 is 28, 4 times 7 is 28. And this is a helpful fact in mathematics because sometimes it's easier to remember one multiplication sentence than it is to remember another. So I know a lot of people may remember their 4s much easier than they'll remember their 7s. So if you run up against something like 7 times 4 and you just can't remember what it is, you can reverse it, do 4 times 7, and you'll get the exact same answer. So let's go back to our problem. So part C again asks us to use this property, this idea that the order of the factors doesn't matter, we'll still come up with 16, to come up with a scenario that can be applied to this situation and justify our answer. So I'm going to take what some might see as the easy way out, but I'm just going to reverse the scenario that's been given to us. And remember, the scenario that's been given was that Caroline has 8 boxes with 2 toys in each box. We can reverse that scenario and say Caroline has 2 boxes with 8 toys in each box. Okay? And just like we drew the picture up here of the 8 boxes with the 2 toys in each box, we can draw 2 boxes, and they need to be a little bit larger, and we can put 8 toys in each box. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And the equation that would go along with the scenario and the picture would be, let's scroll down a bit, 2 times 8 equals 16. And in this case, the 2 represents the boxes, the 8 represents the toys in each box, and the 16 still represents the total number of toys. So even though this was a 3-part question, and each part kind of built off the previous part or built off what we understood in the rest of the problem, I think it's still pretty straightforward. Excuse me while I make some corrections. My handwriting is just looking really crazy right now. But I think walking through it together made it make sense. And a couple of things that I want to make sure that you walk away from is this idea that when we're given a scenario and we're talking about equal groups of something, 2 boxes with 8 toys in each, for instance, it's helpful to draw a picture so that we can make sure that we really understand what's going on in the real world with the math. And it is also very important that as you are writing equations and you're finding answers, that you're labeling those things so that your number sentences actually make sense in the real world. Because one thing I want to make sure that everybody takes away is this idea that mathematics is used to solve problems in the real world and not just to take 2 numbers to create a 3rd number, okay? We use the math to solve problems, and they should be problems that we care about. But when we put those numbers in a number sentence or in an equation, the equation should make sense in the real world. So 2 boxes of 8 toys each is equal to 16 total toys. That makes sense in the real world. Just like up here, we have 8 boxes of 2 toys each that equals 16 total toys. That is something that makes sense. So boys and girls, as you're solving your problems and you're writing out your equations, it's not just enough that your numbers and answers are correct. Your situation or your scenario has to make sense. I hope this was helpful, and if so, please use this video to help walk you through problems in the problem set that are similar to problem number 2. All right, 3rd grade, we are moving into problem number 3 on this week's problem set. I will read the problem out to you twice, then we'll go back, highlight what's important, write down what the problem tells us, and then we'll go through each of the attached parts, part A, part B, and part C, and answer the questions accordingly. So the question says, Mr. John used a total of 28 quarts of oil when working on his trucks. He used 4 quarts of oil for each truck. How many trucks did Mr. John repair? I'll go ahead and highlight that now because ultimately we're going to have to answer this question. How many trucks did Mr. John repair? Part A says to represent the problem using both multiplication and division sentences and a letter for the unknown. I'll highlight the fact that we need to do a letter for the unknown. We need to do both multiplication and division. Part B says to solve the problem and show your work. So part B is actually asking for the answer to the question, how many trucks did Mr. John repair? Part C asks for an explanation for how multiplication and division can be interchanged to find the unknown. Okay, so let's go back up and let's begin. Before we even jump into part A, let's write out all of the information that the problem gives us. So we'll start with the 28 quarts of oil. So we have a total of 28 quarts of oil. 28 quarts is our total. He used 4 quarts for each truck. So we have 4 quarts in each truck. And we will use the letter T to represent the missing number of trucks or the unknown number of trucks. And I'm just going to use the pound sign to represent number, unknown number of trucks. All right, so we essentially have three values. Can't really call them numbers because T is an unknown value, but we have the value T, we have the value 4 quarts that's used in each truck, and then we have the value 28, which is our total. So let's give this a shot. Let's try to represent this situation using first division. So 28 quarts in all divided by the 4 quarts used in each truck should tell us the number of trucks, okay? So that is one way to represent this problem using a letter for the unknown. So we've addressed the division portion of it. Now we can actually use these same 3 numbers, rearrange them a bit, because there is a relationship between multiplication and division. There's an inverse relationship. Inverse means opposites. And we can use that inverse relationship to represent this as multiplication. So we'll do that. Let's say we did 4 times the number of trucks. So that is 4 quarts of oil times the total number of trucks. That should tell us the total number of quarts of oil we've used in all. So let's write that one out. So T is the number of trucks times 4, which is the quarts used in each truck, will give us the total amount of oil used across all the trucks. So we've represented our problem using both division and multiplication. And just by thinking through this or actually doing the division, we should be able to find the missing number of trucks. So let's do that for part B. I choose to use the division sentence. So we'll do 28 divided by 4 equals T. Let's do some long division. So that is 4 into 28. 4 goes into 28 7 times. 7 times 4 is 28. 28 minus 28 is 0. So 7 is the total number of trucks. So Mr. John repaired 7 trucks in all. Okay? Pretty straightforward. It's just a matter of making sure we understand our multiplication tables. And we actually looked at 4 times 7, 7 times 4 in problem number 2 when we were talking about the commutative property. So that actually worked out nicely and was very convenient. Part C, and I'll highlight that since we've done some scratch work nearby. Part C says explain how multiplication and division can be interchanged to find the unknown. Okay, so the first thing that we want to point out is multiplication and division are opposites or inverses of one another. So multiplication, and actually, you know what? Instead of writing this out because it's going to take too long, I'm going to type. So multiplication and division are opposites or inverses of one another. We can divide the total amount of oil used by Mr. John by the amount of oil used in each truck to determine the total number of trucks. We can also use what we know about multiplication to figure out what number we need to multiply the amount of oil used in each truck by to find the total number of trucks. Okay, so this is a quick explanation of how the opposite or inverse relationship of multiplication and division can be used to help us find the unknown value in this particular question. And we explained it here, but we actually modeled it or wrote it out here, okay? And as always, if writing it out using numbers and symbols is a struggle for you, you can always draw a picture to come up with the same answer. So before we close out this question, I'll go ahead and demonstrate that for you as well. So I'm going to go back up to the space between part A and part B, because that's where I would have drawn the picture naturally. And I'm going to represent the trucks with these little rectangles. And I'm going to put a 4 inside of each rectangle, because that means I'm using 4 quarts of oil inside of each. So that's 4, 8, 12, 16, 20, 24, and one more makes 28. So we have 1, 2, 3, 4, 5, 6, 7 trucks. And those 7 trucks in total use 28 quarts of oil, with 4 quarts of oil going into each truck. I hope this problem was helpful, and I would like for you to use this video number 3, or the video for problem number 3, to help you answer the other similar problems on your homework packet. All right, 3rd grade, this is the last sample problem or example problem on the problem set for this week. And just like the other 3 before it, or the other 2 at least, this is a multi-step problem. This problem has 3 parts, and it is related to the other 3 in that we use some of the same skills and ideas to make sense of this one. So first up, we are given an equation to consider. That equation on your paper is 40 divided by an empty box equals 10. I did not have the option to make an empty box on my sheet here, or to be honest, I just didn't take the time to find the empty box. So we'll use an X as a placeholder. So I have 40 divided by X equals 10. Part A says, consider the division equation. What multiplication fact will help you find the number that best fits the box? Explain your thinking. Part B says, what would a number need to be multiplied by to double its value? Write the number below and explain how you know this is the correct number. Part C, consider your answer to part A. If the number that fits in the box were doubled, what would happen to the quotient? Show your work and explain. So as always, there are going to be some things that I want us to highlight to make sure that we are reading the question correctly and considering everything that we need to do. So part A, what multiplication fact will help you find the number that best fits the box? This one is pretty straightforward, and we will rely on what we know about fact families to help us answer that. Part B seems like kind of a question that comes from left field, but we use the answer from part B to help us with part C. But we're being asked, what would a number need to be multiplied by to double its value? And part C is asking us to use that mystery number, that number that when we multiply it by other numbers doubles its value, to answer this question here. And then we have a vocabulary term, quotient. Quotient, again, is the answer to a division problem. Okay, so let's scroll back up to the top and answer part A. Let me switch over to a pencil. So consider the division equation. What multiplication fact will help you find the number that best fits the box? Explain your thinking. So when I see 40 divided by a missing number equals 10, my mind immediately goes to the fact family that involves 40, 10, and our missing number. So to help you think through that, let's just come over here. 40 divided by our missing number equals 10 is related to 10 times our missing number equals 40. When we look at it this way, I think it's pretty clear and pretty obvious that the missing number is 4. And we'll just go ahead and write x equals 4 here. And we can double check our answer to see if it makes sense. 40 divided by 4 does indeed equal 10. 10 times 4 does indeed equal 40. And when we're asked to explain our thinking, we can explain our thinking by demonstrating or by using the fact family. And just as a reminder, the fact family is a relationship between three numbers that involve multiplication and division. So this particular fact family is as follows. 40 divided by 4 equals 10. 40 divided by 10 equals 4. So here we can see kind of that inverse relationship when dividing by 4 or dividing by 10 in this part of the fact family. Now we can look at the multiplication side of the fact family. 4 times 10 equals 40, and 10 times 4 equals 40. Okay, so the way that I would explain my thinking here in this problem is I would say 40, 10, and 4 are all related in the fact family. Let me create some space for myself. The fact family to my left. Okay, and that seems to me to be a pretty straightforward explanation of what's going on there. Let's erase the green here, and then let's get down to part B. And we'll re-highlight this idea of multiplying a number to double its value. To double something means to make something twice as large as it currently is, which also means to multiply by 2. Anytime we multiply something by 2, we're making it twice as large. So, for example, 2 times 6 is 12. That means 12 is 2 times bigger than 6. 2 times 10 is 20. That means 20 is 2 times big as 10. And when I say something is 2 times as big as something else, it means it takes 2 of these to equal 1 of these. So for instance, 10 plus 10 equals 20. It takes 2 10s to equal 120. It takes 2 6s to equal 112. That's what it means to double something, okay? That's what it means to multiply something by 2. All right? I hope that makes sense. So writing the number below is here. Explaining how we know it's correct. I mean, we modeled that it's correct by doing something like this. 2 times 6 is 12. 6 plus 6 is 12. 2 times a number is doubling that number or making that number twice as large. Okay? I hope that is clear. Part C says, consider your answer to part A. Our answer to part A was 4. Okay? If the number that fits in the box were doubled, what would happen to the quotient? So the answer to part A was 4. If we double 4 or multiply 4 by 2, we get 8. Okay? If we go back up to the original problem, it said 40 divided by x equals 10. So what happens if we replace 4 with 8? So 40 divided by 8 equals 5. And up top, we had 40 divided by 4 equals 10. What do you notice? What I notice is this. When I double this number, my quotient is halved, or my quotient is cut in half. So when this is doubled, this is cut in half. 5 is half of 10. 8 is 2 times 4. So that would be my answer. When I double the number in the box, my quotient is cut in half. We can say cut in half, we can say that it is halved, we can say it is reduced by half, but all of those terms essentially mean the same thing. Doubling this number here, when we compare it to this equation, cuts this number in half when we compare it here. So that is it for this week. Please use this video for problem number 4 to help you with the related problem set. We'll have a new set of videos up for next week to help you work through next week's problem set as well. Thank you for watching. Good luck and happy learning.